Hello, myself Vaishnavi and currently pursuing my BA in Srivenkateswara College of Engineering. I'll be discussing on the topic unsupervised learning composite network to reduce the training cost of deep learning model for colorectal cancer diagnosis. In this abstract tells that the deep learning facilitates a complex medical data analysis and is increasing being explored in the colorectal cancer diagnosis. However, the training cost of this deep learning model limits its real world medical utility. In this study, we present a composite network that combines deep learning and unsupervised k-means clustering algorithm, that is RKNet, for this automatic processing of medical images. The RKNet was more efficient in image refinement compared with manual screening and annotations. The training of this deep learning model for the colorectal cancer diagnosis was accelerated by two times with the utilization of RKNet processed images. That is, better performance was observed in training loss and accuracy achievements as well. In the RKNet, it could be useful to refine the medical images of the ever expanding quantity and assist in subsequent construction of artificial intelligence model. Coming to the introduction, the colorectal cancer, that is the CRC, is the third most common malignancy globally and the second leading cause of cancer specified death. The accurate characterization of the CRC for each patient, that is vital for precision therapy. The artificial intelligence, particularly machine learning and deep learning, is increasingly used to analyze the complex medical data and build the predictive models for CRC diagnosis. However, this training large scale neural networks is time consuming and costly, requiring high quality. The well annotated data, the manual annotation, especially for medical images, is labor intense, often requiring expert radiologists. To address these challenges, unsupervised learning techniques like K-means clustering offer solutions by efficiently organizing the medical data. In this study, a composite network, that is ArcNet, integrates DL with k-means clustering to automate the selection of the relevance of the slices for CRC diagnosis that demonstrates the model ability to optimize the performance compared to the manual records. Let us discuss about the background and challenges in colorectal cancer diagnosis. The colorectal cancer, the CRC, is the third most common cancer globally and the second leading cause of cancer related deaths. In the early detection, it is critical to improving patient outcomes, and the artificial intelligence, especially the deep learning, plays an increasingly important role in medical imaging for CRC diagnosis. However, the development of this AI models for analyzing the complex medical images, it faces a significant challenges. This includes the need for powerful hardware, large datasets, and time-intensive training process, making the creation of effective deep learning models both are costly and technically demanding. Let us discuss about the ArcNet architecture and its components. The composite network, the ArcNet, consists of several key components that were designed for medical image processing and classification. First, it has a medical image processing batch process, that is raw data, that converts the image into readable formats while protecting the patient's privacy. In the second, a pre-trained custom model switches between the models, that is based on the data format. Third, an unsupervised classifier using the k-means clustering algorithm, or the pre-classifies data with the number of clusters that is set to k is equal to 2 to filter irrelevant images. In the fourth, classification results are saved as CSV files and the images that are sorted into folders, where in the fifth, an image processing models with an open CV converts the images to required formats, where based on the classification of these results. Finally, a mobile net VT neural network that is based on the inverted residual structure differentiates the transport images, that has optimizing feature extraction and computation of efficient classification. There is we import this, and data loader performs its action and sends it to DL pre-classifier, where the game is clustering classifier is conducted and image is stored and the output is given. In the evaluation indexes, to evaluate the performance of the model trained on various datasets, there is five key metrics that are used. First, a true positive rate, that is a TPR, measures the probability of correct positive diagnosis, that is calculated as TP that divided by TP plus FN. Where second, it has a specificity where it indicates the probability of correctly identifying the negative case, that is defined as TN divided by TN plus TP. In third, a false positive rate, that is FPR, reflects the proportion of negative incorrectly diagnosed or positive, that is calculated as FP or FP plus TN. Fourth, the false negative rate, that is FNR, measures the proportion of positive misclassified as negative, defined as FN divided by TP plus FN. In the fifth, a model overall accuracy represents the proportion of correct prediction where both positive pictures and both negatives among all the cases is calculated as TP plus TN or divided by TP plus TN plus FP plus FN, where this matrices helps to access the model diagnosis where the error rates are both positive and negative. In the evaluation metrics, a metric, true positive rate, it has probability of correct diagnosis for class 1 patients. Specificity, the probability of correct diagnosis for class 2 patients. False positive rate, a probability of class 2 patient that is diagnosed as class 1. False negative rate, probability of class 1 patient that is diagnosed as class 2. It has accuracy where the probability of correct diagnosis for all the patients. Coming to the advantages and limitations of ArcNet, the advantages, it has a high efficiency in data filtering for complex medical images. It has an automatic removal of irrelevant images, reduced manual labor in screening and annotations, improved performance of deep neural networks. In the limitation, reliance on pre-trained models with mixed medical images. It has a limited to processing radiologic images only. There is a only need for further validation in different datasets and algorithms. Coming to the conclusion and future direction, efficient image refinement, where the RKNet demonstrates the efficiency in eliminating confusing images that is unrelated to colorectal cancer, simplifying the quality control. In the improved model performance, the network is not only decreased and the overload of manual screening, annotations also performs a deep neural networks from the foundation. In the future potential, the RKNet shows the promise as a method for automatic refinements of medical images on the large scale, potentially that assessing the further construction in the networks for various medical applications. Thank you.